Today I am going to present my study on comparative assessment of spectral matching algorithms and their utility in mineral mapping using airborne data across India, particularly in this.
Next.
Mineral exploration, geology, defense, agriculture. So it has wide range of fields. What is the most important feature here is that imaging spectroscopy is used to spectrally delineate and discriminate different rocks and minerals using their diagnostic absorption features arising out of interaction between radiation and land surface. Another important aspect is that
फिर उसको स्लाइड करो.
Yes.
so in present study I have taken three data sets near Bhilwara, Umra region, Udaipur and Ambani. So two from Rajasthan and one from Gujarat. So every data is collected. The data set includes level 2 reflectance data, process for atmospheric correction and noise reduction. These sites are taken because these sites are known for their diverse mineral composition, making them ideal for evaluating different mineral mapping techniques. This is the flow chart of the various steps involved in mineral mapping. So after receiving raw data, pre-processing is done to remove errors in terms of radiometric error, geometric error, or atmospheric error. Again, the spectral resolution of USGS library is greater than the average image. So again, resampling of the spectra obtained in image and USGS library is done. These are some because the data which we receive, its dimensionality is very large. So some dimensional reduction techniques are employed, like minimum noise fraction. I am particularly going to deal with three. I am comparing three spectral matching algorithms. Spectral angle method. Second is CEM, constant energy minimization, and third is adaptive poisson estimation. For analysis and mineral maps, total 390 out of 425 bands are selected, which are lying in the region of 0.38 micrometer to 2.5 micrometer, which covers VNIR sphere, that is short wave infrared region. So, since the success of target detection and mapping depends on the quality of input and the spectrum, a homogeneous area in terms of spectral signature of objects which does not vary spatially is considered a region of interest. Three spectral matching algorithm were implemented to map tar, dolomite, calcite, jarosite, quartzite. These are the results.
Okay.
Dolomite, jarosite, quartzite. Now, to create robust reference data, a popular voting scheme was implemented. So, what is basically done here? The sorry, I have not included mass filtering here. I am using these three.
Three only.
Actually, what space data, space mode data. Currently, I am dealing with three. So here, the three binary classifier output was tag pixel. Out of three, if the two agrees,
Your faculty over there, anybody? Your faculty over there? Anybody? Your first is N.V. Patel and first is Manoj Singh. So
He is a research student in the part-time format. And
Okay.
He is leading the
your background is geology,
not this.
physics, and you are
sorry to interrupt. He is the principal of Interdisciplinary.
okay. So you are putting your foot into the geology and also in the hyperspectral domain.
Physics aspect also.
Okay. So next slide, please. Okay, next. Introduction after introduction. Introduction. Next, please. So these are the images of the some minerals available over there. Next,
Yeah, this size.
next methodology. Okay. Average NG after pre-processing. What pre-processing you apply?
Means we reduce the data.
No, pre-processing is correcting the error.
Pre-processing, okay. Means we remove radiometric corrections or atmospheric corrections.
Okay. Then what about georeferencing? Georeferencing is done. Georeferencing required that where exactly the objects are, because remote sensing data sets, if you get the level 0 or level 1, they are not georeferenced. So mostly the people who are working in the agriculture using hyperspectral or geologists, they don't know georeferencing. They don't acquire the remote sensing georeference data. They acquire the raw data sets on level 1, radiometrically calibrated only. Then they do all processing at their own. I have done also all processing at my own. Atmospheric correction, geometric correction. Okay, then I have better control over the data sets. Minimum noise correction you have applied for the dimensional detection.
Yeah.
But before that, you have to also ground truth and mark the point, because when you do a minimum noise correction or principal component analysis or any, it will change the values.
Okay.
It will change the values. It will fix the similarity at the end and variability in the first spans. So to reduce the dimensionality, we are using the MNF. So
Because selection of band is essential.
here not the selection of the band is happening. Here happening that you are suppose have the 100 band. In 100 band, all 100 band are not giving the data set to me. And the similarity is not the information. The variability is the information. So in minimum noise correction, in principal component analysis, we are trying to map the variability of the data sets in the first 4 or 5 components, and we only analyze those to reduce the time, computational time. We are using the MNF or PCA.
Because without MNF computation,
It was a lot of time. It's a 242 band. It continues for a number of years also. Sometimes the large image is there. So that also the because georeferencing is not mentioned. Georeferencing either do after or before also. Both the way possible. After MNF also you can do georeferencing, because georeferencing is essential for ground truthing. That you are saying that this dolomite available here, is it? Okay. Remote sensing is like a black box. Whatever you interpret, the people will believe only based on the ground truth that you have done something and you are saying that something is over there. Okay, please next. A spectral angle mapper is not the good algorithm. It will not work because it works on the way 2 vectors. One vector that you are giving, that this is my standard vector and this vector of the image, and is there is a match.
for same site analysis in space one data also for ISTAR memory. And I found that
SAM is insensitive.
yeah,
SAM is insensitive. Have you applied SFF, spectral feature fitting, spectral information divergence? But spectral information divergence also work well. I mean, used in agricultural mapping and it works well. compared to all this. So try to use those. Next, please. I've done a lot of study in my BTech and MTech and PhD projects, so I know everything. In remote sensing specifically, not in GIS. You are saying something on ground. Next. That curve you have put it, na? Spectral reflectance curve. Top one, first one. Yeah. That is standard curve. From your study, the curve is not available. There is a curve, spectral curves. This is a standard curve. If you get curve for your study, definitely it is a different than this. Because when you apply atmospheric correction, still some atmospheric effect will remain. हम करने के बाद भी एटमॉस्फेरिक इफेक्ट तो थोड़ी तो रहती है, पूरा ऐसा नहीं आता है, ये तो पूरा लेबोरेटरी डेटा है, ये लेबोरेटरी डेटा है। हाँ, वो लेबोरेटरी डेटा अलग होता है, वो कॉन्टैक्ट प्रोब से लेते हैं, कभी बार एग्रीकल्चर में हम कॉन्टैक्ट प्रोब से लेते हैं, एक लीफ रखा और उसका स्पेक्ट्रल रिफ्लेक्टेंस निकाल, तो दैट इज अ कॉन्टैक्ट, एंड व्हेन वी गो इनटू द स्पेस इट इज ऑन कॉन्टैक्ट, so that also different, so many things are different. So if it is better if you put your own data in next presentation somewhere else, because whenever you put presentation, that should be your data set, your study data set. Spectral curve must be from your study area. You get something and you try to map those curves, one standard curve and your curve of one particular mineral. That helps a lot to understand the
deviation.
Yeah. So what is the difference?
Our accuracy part, it reflects how much we are deviating from this standard.
Yes. Usually people will appreciate that. Okay, that's okay. No problem.
Right?
Scholar in Physical Sciences Department and Vikas. Today I am going to present on effect of substrate temperature on optical properties once laser deposited with
Cadmium,
selenide.
selenide. Okay. Thin films.
So cadmium indium selenide is belongs to 3264 semiconducting compound family, and the first work on this material was done in 1955, and we are the first one to report alpha phase in this material, and it shows excellent properties for optoelectronic devices. So transmittance spectra, from transmittance spectra we can see that this film shows good transparency in the visible region, and as the substrate temperature increases, the transmittance also improves due to improved crystalline. And from the transmittance spectra, we calculated absorption coefficient, which was 10⁷ meter inverse, and it supports the direct band gap nature of semiconductor. Refractive index decreases as wavelength increases, which shows normal dispersion behavior. Extinction coefficient shows strong light matter interaction. Optical band gap. The optical band gap shows variation with the substrate temperature, and this variation is due to change in the crystallite size. Imaginary dielectric constant represents the energy loss within the material, and variation with substrate temperature indicates that there are modifications of electronic transitions, and real dielectric constant also there is relation with the substrate temperature because of the changes in polarization. Loss tangent gives information of dielectric losses, uh, and a higher value of loss tangent means increased state of defects or scattering in the material. Perfect energy was calculated to estimate the degree of defects, and lower value means improved crystallinity. Optical conductivity, variation in optical conductivity shows that there is direct electronic transition. Well, that is volume energy loss function. It represents energy loss of moving electrons within the bulk material, and its variation represents that there is changes in electronic structure. Surface energy loss functions, that is self. This also as the substrate temperature varies, the surface electronic structure varies. From the FTIR spectra, we confirmed the CDSC and ISC bonds. No significant impurity peaks were obtained, and it confirms successful formation of CD2SO4.
That you done at your own? That you have done it at your own?
My team's working this.
It's Fourier transform.
So to conclude, CD2SO4 synthesis were successfully deposited using pulse laser deposition with controlled substrate temperature. Optical studies confirm high absorption coefficient and direct allowed band gap transition. The optimal temperature was 553 Kelvin. And from all these optical studies, we can say that if we use this material, we get better results for the we can go towards the applications for optical devices.
Okay, so pulse laser is used for what purpose?
For the purity of film. Thickness control we can get from pulse laser deposition.
The pulse laser used for which practical application?
Pulse laser.
Yes.
Is practical.
Because we are studying something based on the practical study, some limitations are there, that we want to enhance that system by this. Pulse laser is also used in measurement. Not come across? Okay, go to your first slide. Because whenever you are present, you also check that what are the application areas that. Yes, next. So you want to improve the by deposition, the accuracy of the pulse laser, or
No, sir.
Actually, pulse laser is the ready-made instrument through which they are deposited.
Position of thin film.
what is the purpose? I don't get your purpose. What is the finding of why you are finding out deposition?
We have deposited this material, CD2SO4, study on it for applications of optical applications, optical devices.
So are you getting the
Yeah, actually, it is a deposition technique.
Okay.
Onto the substrate, they were prepared a film,
okay?
and that film can be utilized for the optical application.
Okay.
So, yeah.
Let not get it is my
Yes.
what?
It is a semiconductor physics.
Yeah. So what? I'm in the physical physics like that. No issue. So we'll the help of the regulation.
Good morning to good evening to all the dignitaries and participants. My name is Rohit on this side. I'm a student at Technical College of Applied Sciences, and today I want to present my work on the variability analysis of tropospheric over different sites of India using GIS techniques. So as I have the time constraint, so I would like to move forward to my work timeline.
That introduction is keep.
Yes. So basically, I have done this work with the help of change satellite data. It has been proposed by the South Korea space agency, and that change stands for geostationary environmental monitoring satellites. And it was launched in 2020, but it has started providing the data from the December 2022, and I have collected all the data from the 2023 to 2025. And it has the spatial coverage of -5 degrees south to the -45 degrees north, and 75 degrees to the 145 degrees. That's its spatial coverage area. And the positive point of the positive point for the satellite is that it shows the 8 times data in a day. So the total resolution is 8 times in a day. And it has the specifications of the satellite that it's provide. I mean, it's for the environmental monitoring. It is the environmental monitoring satellite. So it provides various monitoring items like ozone gas, sulfur dioxide. It gives nitrogen dioxide and tropospheric nitrogen dioxide as well as the stratospheric nitrogen dioxide, formaldehyde, air bubbles, and many other properties that we can get from the jet. So the spatial resolution of this satellite for the gas is 7 km by the 8 km, and for an aerosol it is 6 by 8 kilometers. And it is basically working with the UV visible spectral range. Here I have done. So this is how it captures the data. I mean, we have to take the time to get the data from the particular region. Here I have taken the flag which shows such type of data for Costa Rica, and it shows the area. I mean, this portion we are not getting unfortunately, but otherwise I have worked on particularly the magnetic plane, and I have done this analysis for the different sites, but I have categorized those sites into the 4 different categories. That is the apartments, metro cities, property area, and the stable site. Here I have picked the stable sites for just to clarify that, and just to check that whether JS is providing the data in a well manner. I mean, it's providing the digestive data or not, because we especially all know that stable site doesn't give too many variability into the emission rate of the tropospheric envelope. So I have picked one side from each category. So from the thermal power plant, I have picked the Vijay power plant, and from the metro city, I have selected Kolkata. For the domestic I have selected the Amritsar, and for the stable side, I have picked the Palsoon, that is situated in Rajasthan. It's a very remote area and a small rural area. I have done the diagonal monthly and yearly analysis for the tropospheric data of these sites. Diagonal analysis, we should do the diagonal analysis to check the constant variability of the tropospheric data, whereas the monthly and yearly analysis provides us the long-term trend analysis for the particular gas variation and gas emission variation. I have done, I have picked the data for the 10-15 IST because we can get the data for this time throughout the year. So this is how I have made the images with the help of Python codes into the Python. And I have picked the first date of each month from January, February, April, November, December. You can see the variation for that particular area. As I have mentioned that I have picked the thermal power plant. So you can see that how it is showing the variability into the emission of the I actually forgot one thing that why we need to do this analysis, because as we all know that it's one of the leading contributor to the pollution of atmospheric pollution, and there are widely two sources, and anthropogenic activities and as well as the fossil fuel combustion. So, and it takes place also when it's lightning heavily during the monsoon season. But it's not pivotal as the anthropogenic activities and fossil fuel burning does play the role for the emission of the tropospheric group. I have done this graphical analysis and I have done the point value extraction for that. I have done point value extraction with the help of Python code and given the particular network for that particular area and get those values in Excel sheet and develop the monthly diagonal as well as the yearly analysis. Here I have done the yearly analysis. I mean, I have taken the average of the entire month. You can see the variability how it shows the variability in the winter season. Same, I have done this for the metro cities. I have it the same images like I have done for the Vidyachal. And this is the graphical, and this is the monthly, this is the diagonal analysis, and this is the yearly analysis for that. And I have picked up 9:15 a.m., 10:15 a.m., and 11:15 a.m. for the diagonal analysis. And this is the recipe burning for the Amritsar. And you see that how it's showing the changes in the emission rate of tropospheric in after in the October and November. And this is the big graphical analysis for that. As we move to the cycle, you can see there is very no to this tropospheric and anthropogenic activity. So hence the emission of the tropospheric activity more and less compared to other sites. And just to check that how it's playing a role and how metro cities and power plants are playing a role in the emission of the tropospheric NO2. So we can see that comparison that when there is nothing, I mean, very less populated area or a rural area, then it would be less for the emission for the tropospheric NO2. As we move towards the metro cities and the power plants, it will increase this and in a very huge scale. So at the conclusion, I would like to say that thermal power plants are the leading contributor to the NO2 emission across all the sites. During the monsoon season, we can see that NO2 emission decreases in the urban areas. After the urban site shows the peak in the month of April, May, November, and December, October, and November. We have chosen, like I have said earlier, we have chosen also in Rajasthan with minimal NO2 emissions to verify the accuracy of JET data. And with this type of analysis, this type of analysis allows us to monitor the activities contributing to the emission of the tropospheric activity.
Okay.
And I have made just a small video regarding how it changes. I actually failed to control the speed.
One question is for you that how you derive the NO2 map from the remote sensing data sets inside you. How you derive the NO2 maps? What processing you have carried out? Is it available?
Yes, sir. We have to make it.
You are running this software? You are running this software? Which software? Okay, it is okay that you have derived this, I think, yearly change of the NO2 map. But have you relate with the past data that
This GEMS is providing the data from 2020 December 2022.
Okay.
So I have taken the data from 2023. This is the analysis of entire 2023 and 24.
Okay.
That will be done. And I have some other plans.
because presently lot of renewable energy approaches has been implemented and used at a larger level.
Yes.
So is there effect, positive effect of that or not? Still, the NO2 emission of the thermal power plants are higher.
It's increasing day by day because the anthropogenic activities and human needs are increasing day by day. So it's going to be.
You have specifically selected the area of the thermal power plant and somewhere the fields where the burning is happening, etc. So if that thermal power plant, very much concentrated on thermal power plant, because if you see the present power demand is reducing as per the statistical data sets. So if the power demand is decreasing on the thermal power plant, then definitely NO2 emission will be decreased.
Sir, as you can see that it is because of the implementation of solar panels.
So much renewable, solar, wind, and many other also people.
But it is as per my understanding and my view that it is starting, I mean, in a wider way after the 2024. So I will do the comparative analysis for sure.
Yes, because
And, but after the 2023, I can use it
What-
with the help of James, correct?
why I'm saying you, because when you say anything about the past, that will not lead you in the research work.
Yes.
So what is the present scenario? You relate with the present scenario. Is there any change really, positive change or negative change? Still, thermal power plant are generating the same amount of the amount due to the power generation, or other problems are there still. Then it is a good research technique.
Thank you.
Yes, yes, sure. Everybody has.
What basis did you choose the cost?
This topic is continuous monitoring of dam subsidence using Sentinel-1 ISTAR. This is a case study about the ISTAR dam. So dam is one of the critical infrastructure. Failure definitely leads to a catastrophic impact along with the flooding, loss of life. Subsidence is something which is a structured distress which occurs over a period of time over dam structure. Because dam structure is quite huge. Always as well as climate change, extreme weather events, there will use this more distressed infrastructure and making them more and more vulnerable. We have ground instruments which are quite precise to monitor all this, but partially the structure is big and they are always on the remote side. So we can use remote sensing technology to monitor that. So yeah, the principle of ISTAR, so that is differential synthetic aperture spectrometry. So this is kind of a technique which uses two different satellite images. It compares the phase difference of that over a different period of time. Then we use an EM to remove the topographic effect of that and isolated information that how much particular land is being subsidized by using these two particular images. This has capability to give a millimeter mm level sensitivity. It generates an interprogram image like this, which helps to get and structural settlement. So as I mentioned, the study area is ISTAR 3, also known as tungsten belt. It is in North Sikkim, region of India. Construction of this dam was done between 2008 to 16, around 14,000 crore rupees, but due to flooding, it collapsed on 3rd and 4th October 2023.
this was one of the image published by NRSC that there was a dam before flood and then the dam was totally collapsed after the flood event. So what we did was we took the Sentinel 1C band and did the whole because this is definitely provided by ISTAR and that opened this program. We used the IW mode of the IW mode path band with partial resolution of 5 meter by 20 meter. Sentinel-1 is an open source data set which has a 6 days repeated period. But for the study, as the dam was construction was completed in 2016, so we took 2016, then 2018, 20, and 23. Dam was collapsed on 4th October, so we took the latest available, that was 25. And the main consideration to the data during the data collection was as thinking as a snowfall. So whenever we took the snowfall data, the deformation was showing much more, which was not practically possible. So we did not take those data sets and considerably only those data sets that when there was no snowfall. So the methodology and the whole processing was done using Snap software. We have STAR1 and STAR2 two images, year 1 and year 2. We use CM or register rate. And then we found out that interprogram formation was done. Then these are the steps through which we enhance the images, reduces the noises, do the multi-looking of the image, get the which particular pixel has been more, which particular pixel has been deformed with respect to each other. Phase filtering was done, and then we get phase displacement. After phase displacement, again terrain correction is done to get the accurate displacement map. After that, we also we substitute to the area of interest that was the dam site. So this is the result. We can see that as in from 2016 to 18, there was almost negligible displacement, like 0.02 to 4 mm. But when you compare 2018 to 2020, there are around 30.8 mm displacement. But when it comes to 2023, the maximum displacement has gone to 650 mm. And we can also see that here the displacement was started, then again here it increases, and here it was significantly increased. It's like the whole dam has collapsed across the single chainage line. Yeah, so the final results are that partially deformation pattern is obtained across the chainage. There was approximately 640 mm displacement was being recorded on a vertical deformation, and we can also see that settlement has been specific to that structural vulnerability. And temporal comparison, we can see a progressive deformation trend. As dam is one of the most important, we need a method to adapt frequency and force so that we can do the early detection of this, and there is no such collapse of dams occur. So I would like to conclude that Sentinel-1, which is an open source, is definitely one of the reliable source which can be helped to monitor such dam deformations, and we can save it. We can have an annual analysis at every 5 days or maybe 1 as per requirement. And ISTAR is one of the cost-effective and early warning methods which can help complete conventional ground-based system, because that's quite challenging and cost-heavy also. So we can integrate satellite-based information monitoring, significantly strengthen proactive dam safety management and long-term infrastructure resilience. So these are few of the references.
Now, is the ISTAR 3 dam
Yes, sir.
is a concrete dam?
Yes, sir.
Is a rigid dam? It is a rigid dam.
PG.
The area is also the hilly area.
Yes.
So the rocks are there. Now you have studied the topic. What are the reasons why the subsidence is taken place?
So basically, one is definitely snow and induced the dam. And why it's competitive, definitely because government has passed it and engineers have built it.
Yes.
Main focus was to prove that this technique can help to monitor the dam. But how we can prove it, because we already have this dam failure, so we can go back and prove that if this has been failed, let's see what was happening before it failed, and then make a full algorithm or a technique to monitor each and every dam.
Okay. So how you achieve the level accuracy in an interferometer?
Yeah, so basically interferometer, how it works is we have a satellite has particular, it works on particular orbit. It collects the data set. We have an image. We do the image to image comparison, and then based on that vertical distancing we measure. So this study was also done for Josimas, and then the government declared it for to them out.
Okay.
This is the same technique.
Okay. Okay. Then that you elaborated that image matching you have done.
Not phase matching, not
Phase matching.
phase.
So phase matching, what it gives? It is directly giving you the elevation data sets.
First, we have to go, kind of, as I mentioned, the whole process. So, we have to criteria. This particular line of sight is same.
Yeah.
Based on that, we get an interferogram. It checks comes that on the same when I took first image and when I took second image, what is the phase difference between them?
Okay. So is it having a side looking also or nadir looking only?
Both.
Both are there. So you are taking one is a nadir looking and second is a side looking. And both the for same place you are analyzing those both the differences. So then it is possible
Yes,
to
we
get
are going same side as well as for
nadir looking.
nadir looking. Then we can get the phase. Not we cannot get the phase.
Yes, then it's possible. It's good if you are getting level accuracy. But it is ground truthing also required because you are saying on past data. So for now it is easy to say. But if we really monitor the Sardar Sarovar Dam, suppose, and we really check it out also with the conventional surveying techniques, that is the levels are same or marking or not, then we can say yes, that technology is really promising in the years to come.
So that's why one of my research, we use this image from analysis to the original image and compare it with change. That's why we say that by each and every change, the deformation has been occurred.
Yeah. But what I mean to suppose to ask you that you try to study this type of the in wherever the area is snow induced area and concrete dam is there and they may be in the ridge line or the valley line and they are existing in presence. Okay. And do conventional surveying level and techniques and check it out that is there is a match between these two because now this is not existing so we cannot do ground truthing. If really it works wonderfully then it saves the many dams and many people's money of the people and many lives also. So that is I propose from my side that you can also do more study on that. Okay, then we can relate it with the real time scenarios.
Yes, sir, because we already given this to the data that we
Yes.
did this the same. And they are started like government also passed that we will start monitoring them every 30 days.
Yeah, that is good.
That's on paper, so we need to do and they are developing such.
Sardar Sarovar is on the planar area, so it will not happen to that. And snow-induced forces are not there. The area where the snow-induced forces are there, and they are on the ridge line or the valley line, they are problematic because they have the downward side flow, and that pressure is high.
And so, making this construction of dam is started there, and now we are making them using some new technology so that it doesn't get people because the flood occurrence in this season is very much different.
Good. My journey also in MTech IIT Roorkee. It is no wise user. We are the same. And we profess something, we go to the different conferences, we present ourselves, and we get the learning from that people who are in conferences. They ask the questions, we try to write down the questions. Only one problem I realized is that nobody write down the questions. So that is lacking. We are always with the knot. On the poster we are standing, we are with the knot. What is professor saying? What is somebody saying? We try to check it out. Why these questions are happening? Okay? So that is somewhere we have to upgrade. And all the presentations are good. Some people have tried a new way and different area. Okay? Wonderful presentation. But you have to improve yours. When I studied in MTech, after that my confidence is somewhat good. And I started my journey again as a PhD at IIT Bombay. Still, when I joined IIT Bombay as a PhD, initially I feel that I could learn more again because my domain in the IIT Roorkee is multispectral. My domain in the IIT Bombay is a hyperspectral. So I'm saying that I done also work in multispectral. I have done work in a hyperspectral. I don't work in a GIS in my study career, but when the students are coming to me, sir, we need to do this type of the project in the UG, then I learn again the GIS. So learning continues, learning never ends. Even I learned today so many things from these people because I worked up to Modern 4. Beyond, when I was doing a PhD, I have learned Modern 4. Then 4.5, 5.4 is also there. So good learning. Also learn from her that yesterday was good about the methane emission and some product. So it is good study and we all together learn something and develop ourselves. Thank you. All good. Good, kind of good. Now, wherever you enhance, you have to improve, then your study will be go to the any good general and good presentation for the. Thank you.
So, no, thank you very much, sir. I like to add in these things. Today morning, one faculty come to me, a young faculty, and asking me, sir, today is my presentation, and it's my first presentation, just help me out, what will be, etc. You can think they are faculty, right? I'm just asking from which discipline, because I'm working in these conferences last few days, I don't remember each and everything. Just I reply him. Just feel you are teaching a student and display your work, nothing else. It is your presentation. Because you already work, you already prepared, and you have data. Just trying to convey your students. And he have not sure what happened with him. Thereafter he told me, I am not from your discipline, it's okay fine. So it's nothing to be worried. Just think to be that whatever work you did, it should be correct. Best way to deal this. One thing I learned from the start. You're working from A to Z, but if you stop at the X, it doesn't mean it is an end. It might be you need to start from A. X is not a solution, same as Thomas Alva Edison. I know 255 method which is not make a one. Like it's never to be end. Okay? So we are very thankful you from the sir. He's spending very special time from his busy schedule. So on behalf of the entire conference community in ISTAR, we request you accept a small token of the appreciations. So I request Captain sir, please.
Sir, like now PhD, I think you have done MSc earlier. You have done MSc earlier. 99. Now you are doing PhD. It is good. So 13 immigrants.
Sir, we call you.
This is a massive 13 immigrants.
To back to work. Very bad.
Journey never ends.
So I request each participant come to the stage for small group photo. Banner.